Welcome to the demonstration of a hybrid filter for the suppression of common mode, voltage and differential mode harmonics in three-phase inverters with CPPM. So here we are using single-phase inverter. So as a CPPM nothing but with the carrier peak position modulation. So here that will be achieved with the help of this circuitry. Here we are using that. So the generated voltage means the charging voltage from the transformer. So here we are using 12 volt 1 amp transformer. So from here directly to the volts given as input to the transformer. So the output from the transformer is 12 volts AC, and that will be given to this regulated power supply board. So it has mainly two stages. One is rectification. So to convert the AC to DC, we are making use of this 4 diodes. So which will convert the AC to DC. That to pulsating DC we will get from that, and that will be converted into pure DC voltage by removing the pulses. For that we are making use of 1000 microfarad capacitor. So which will provide us the pure DC voltage, and after that given that input to the 12 volts 7 amp battery. So here we are using 12 volts dry acid battery. So which will get the power supply from the charging circuit through the 2 diodes. When it is fully charged, so these 2 diodes will block the current flow from the battery to the charging circuit to protect the transformer and charging circuits. So once the battery is fully charged, so we are going to provide the input to the inverter through this circuitry. So the main purpose of this circuitry is, so while we are running the induction motor, so the inverter principles are different for the resistive loads and the inductive loads, because the resistive loads will work for square wave inverter and sine wave inverters, but coming to the inductive loads, these will work for only sine wave inverter, that near to pure sine wave inverters only. So for that purpose we are making use of this. While we are generating the sine wave, there will be chance of generating of harmonics. So due to the harmonics, the motor will not work in smooth running, as it will run from the AC 230 volts in our home appliances. So in order to provide the smoothing one, in order to removing the this harmonics, we are making use of this circuits while the DC power supply given to the inverter through this one. So then this capacitors and the inductor combination will remove the those harmonics while we are running the induction motor. So coming to the induction motor ratings, sir, which will operated of 230 volts AC with 50 hertz of frequency, and that too sine wave should be there. So for that purpose, so the output from this circuit given as a DC to the our inverter circuit. So on this one we can see one CD4047 IC, which will provide us the which will act as a dual timer here. So timer nothing but which will provide the stable multi-vibrator mode, so which will provide the continuous clock pulses. So that signal of pulses, on and off signal of pulses given as input to the 2 MOSFETs. So here using IRF 540, these 2 MOSFETs are used to convert the 12 volts 7 ampere DC to 12 volts AC with same current. So that signal has given input to our center tap transformer. So there we are using the center tap transformer generally, so which will take the input of 12 0 12. So the 0 will directly getting from the battery positive. So we need to connect the A to the A over here. So the 12 0 12 nothing but the 0 means 0 of this transformer getting directly 12 volts from this one. So we are going to switch the negative between these two polarities, these 2 connecting wires. So this will get the negative pulse initially, and this will get the positive pulse. So based on the on and off in reverse polarity. So if it's this is going to be the output consider Q, and this is going to be the output consider Q bar. So when this on, it will be automatically off state, and when it is on, it will be the off state automatically. So that switching will be done with the help of our CD4047 IC, and there we can see one potentiometer. So 103 nothing but 10 into 10 power of 3 10 kilo ohm potentiometer. So the purpose of the potentiometer is we can change the frequency also. So as of now we set for the around nearby 50 to 55 hertz of frequency. So in that frequency only this CD4047 will generate the pulses. So that will be given as converted into 12 volts AC with 7 amp current. So it will generate the low current signals. So that signal will be converted into high current signals with the help of these 2 MOSFETs. So on this inverter board we can see the one LED which will show the status of this inverter board, and the remaining 2 resistors near the MOSFETs are current limiting resistance for the gate end, and remaining resistors and capacitors are for discharging and charging purpose. So as we know that the 555 timer will work on based on the capacitor and resistor combination. So the signal frequency generated from this one is based on these two combinations. So we set this R value to get the 50 hertz of frequency from this 555 timer, nothing but dual timer. So that's CD4047 IC. So that given as input to our step-up transformers. On this one, so we are providing input of 12012 input to this transformer, and which will provide us the 210 to 240 volts maximum. 210 is a minimum. So why minimum? Nothing but based on the battery voltage and based on the load connected to this transformer, the voltage varies from the 210 to 240 volts maximum. So let us see the demonstration one. So if you want to charge a battery with help of this transformer, you should keep on charge at least for 10 hours, and after that you can utilize the project. And now, so when we on this, so just initial motion should provided to the motor, right? As it needs the starting current more than the usual, so that's why we need to provide that just by rotating this motor. So as the operation we discussed till now, same 12 volts DC, and with help of this transformer, this 4047 IC, so 12 volts AC will be provided, and that will be converted into 12 volts AC with 7 amp, and that is given as input to our 12 volts to 230 volts, which is a 5 ampere rating. Nothing but this transformer can handle up to 1000 watts of load. So whatever the load we are going to use is 60 watts of motor now. So as our inverter can handle up to 100 watts of motor only, but our step-up transformer can handle up to 1000 watts of load.